how this measurement method works.
For this case study is a leading supplier of landfill gas extraction and recovery system located in the Midwest region of the US relies on flow meters from Fluid Component International FCI, San Marcos, CA. For its landfill gas flow measurements, the company has developed hundreds of landfill gas extraction system skids that are in operation worldwide, which is all require accurate gas flow measurement. The biogas is extracted from the landfill through multiple wellhead traps and collected via a network of pipes leading to a common leader. Based on the amount of biogas collected from the system, enough methane can be used as fuel gas for generators that drive turbines to produce electric power. Typical landfill gas extraction system for cogen electric power require turbines, engines, compressors, blowers, pumps, flow meters, knockout ports, and a flare or oxidizer gas unit. Accurate gas flow measurement is essential to the gas extraction system in order to control operation properly at the landfill site. Depending upon the amount of landfill gas produced at a given time, it can be necessary to flare off excess biogas or supplement the gas feed of the electrical generating equipment with natural gas. In addition, flow rate and totalized flow data is reported to the operators and regulatory agencies on the amount of gas being extracted, used and/or disposed of via the flare or gas oxidizer system. Objective. The objective of this experiment is consideration for flow meter selection is its capability to support different or changing gas composition, which means instrumentation and other equipment must be able to measure effectively with large changes in flow rate. In addition, the production of landfill biogas can vary widely depending on the volume of refuse and seasonal changes in temperature and humidity.
For the theory of gas flow meter, a mass flow meter, also known as an initial flow meter, is a device that measures mass flow rate of a fluid traveling through a tube. In this case study, thermal mass flow meter are used. It operates by introducing a known amount of heat into the flowing stream and measuring an associated temperature change. The component include two, which is the two temperature sensor and an electric heater between them. Constant power thermal dissipation mass flow measurement technology places two thermowell protected platinum resistant temperature detector sensors in the process stream, like we can see in the figure 1. The FCI's constant power thermal mass flow sensing technique is unique and is frequently cited for the moist gas application. The recommended meter is the gas extraction system manufacturer, which is the installation of its model ST98 mass flow meter, like in the figure 2. It is highly reliable thermal mass sensing element. Accurate gas flow measurement is essential to the gas extraction system in order to control operations properly at a landfill site. Depending upon the amount of landfill gas produced at a given time, it can be necessary to flare off excess biogas or supplement the gas feed of the electrical generating equipment with natural gas. Okay, for the current application industry, this is the diagram that include in this case study, which is starting at landfill. The biogas is extracted from the landfill to multiple wellhead taps and collected via a network of pipes leading to a common header. Based on the amount of biogas collected from the system, enough methane can be used as fuel gas for generators that drive turbine to produce electric power. The condensate some are then designed to be located at the landfill gas heater, low point catching and removing condensate from the piping system. Next is Konokau function is to remove particulates to filtration. It is a large cylindrical vessel that reduces the velocity of LFG and allow ethane moisture to fall out of the LFG. Next is the blower. The blower provides the vacuum used to collect LFG from the waste mass. It also provides the necessary pressure to push the LFG to the flare or to an energy use device. A flare system is used to combust the LFG, and in many cases is required to control or mitigate other environmental or health concerns. And the Kongen engine is the significant part, where it is a part where collecting thermal energy for the production of electricity, also known as cogeneration. Its solution use a single fuel in a combustion engine, like a gas turbine, to generate electricity. The landfill gas typically passes to a metering system to measure the flow rate of landfill gas that been collected. A continuous methane monitoring system also would be needed to measure the mass flow rate of methane in the system. It is required to collect landfill gas or to participating in a greenhouse gas emission reduction project, where the measurement of methane mass flow rate is very important. As we can see in the diagram, there are 5 volumeter that used in this case study. Last but not least, landfill gas flow is measured at several points in the system to provide landfill operators with critical information such as optimum gas production, control, safety, and reporting.
Alright, next part is advantages and disadvantages. So, in this case study, the model that used for flow meter is model ST98 mass flow meter, which is ideal for landfill gas measurement. Alright, the advantages for this model compared to other is measurement and feature high accuracy to plus minus 1% of reading and plus minus 0.5% of full scale. And other than that, it does not require additional temperature or pressure compensation in order to provide accurate mass flow meter measurement under variable process condition. Alright, next, highly reliable thermal mass sensing element. With this flow meter, it can deliver precision landfill gas flow rate. Alright, the next one is no routine maintenance required since no moving parts. Therefore, it can save a lot of costs for maintenance costs. However, in this model, there is also has disadvantages. Alright, for the first one is this model is a little bit expensive compared to other flow meters. And next one is difficulty in measurement low pressure gases. And also measurement can be difficult due to low density of gas. And actually this model is sensitive to external vibration interface, which can cause the problem while measure the gas flow rate.
And today I would like to present for our case study
Precision gas flow measurements helps turn landfills into green electric power generators. So this is a potential improvement of application gas flow meter. So the first one is higher product throughput and yield. Next, simplify maintenance and reduce use of consumable. Lastly, safe operation and environmental compliance, and its lower energy costs. So basically this 1, 2, 3, 4, 5, 6. So got 6 gas flow meter thermal dispersion was used. So flow measurement analysis, the first step is to analyze the different media and flow instruments already in place. Next, prioritize the potential cost impact to achieve the most significant return on investment. These are some critical measurement application for efficient operation. The first one is pump protection. The second one is plant gases distribution. Next is fluid additive, compressed air compression, and last but not least is boiler, fuel gas, and air optimization. So this is a diagram to illustrate that if we have a verbal dispersion gas flow meter instead of differential pressure with this technology, which is VIP and Vortex. So this is a comparison between differential pressure and thermal dispersion gas flow meter. For differential pressure, this is a common type, which is we got 4 type, which is perforated plate, tap type, vane, and tube bundle. Usually in industry we use vane. And for the thermal dispersion, this thermal flow meter with integral flow conditioner. So in conclusion, which is thermal flow meter with integral flow conditioner is highly recommended use in industry than differential pressure.